Also remember one thing, that when the C compiler stores a string, it just stores a null character at the end of it. A null character is demonstrated like this, so that represents the end of the string. Okay, we will use this property when we try to make a program to find the length of a string. We'll just see when we encounter a null character, we'll know that the string has ended. So null character is stored at the end, which is the significance is that the compiler knows that this is the end of the string. Okay, let us also see how we can take input in a string. For example, I make a, 1 second, if I make a character name 20, then I printf enter a string, then scanf. I can directly use %s, as I've already told you, and name. It's just a kind of a variable which that stores the address of some other variable. Just understand it like a variable that stores address of another variable. So it doesn't store a value of its own. It just, for example, this is a variable a, okay, and if this is a pointer p, so pointer p actually stores the address of a. Okay, so whatever you store in a, if you have stored 5, so pointer p stores the address of a. If you make it 7 and then try to print the value of p, it will be printed 7 because it goes to that address, and whoever is present or whatever data is present at that address, that will be printed. It will become clear if I give you an example. For example, we declare a pointer using star operator. For example, if I create a variable int c, okay, and then I create a pointer int star pc. So see, this refers to that pc is a pointer variable. Okay, now I'm storing c is equal to 5. Okay, and then pc is equal to and c. See, if you remember in scanf we use and to refer to the address. So and c refers to the address of c which is stored in pc. Okay, so now pc has the address of c. Now let us see what will be printed. For example, if we want to print the value of pc, so we'll print it like this: printf %d star pc. So star pc means pc refers to the address, and star pc means that the value at that address will be printed. So what will it print? It will print 5. Now see, if I change the value of c, for example, if I make c 7, now I again try to print the value of pc. I mean the address of pc, %d star pc. So now this will print 7. Because PC doesn't have a value of its own, it only refers to the address of C. So whoever lives at the address of C, that guy will be printed. Okay, if you change the value of that address, so that the value of star PC will also be changed. Okay, I hope it is clear. It's just that much. Okay, sometimes we can also print the address like this. You can find a statement like this: printf address of variable. This is the format specifier for pointers, and for example C was we were using C here. So and C is the address, and pointers are the variables which store addresses. So if you use star %p and then you try to print and C, so it will give absolute address. It can be something like 5a 67238. In these kind of 8 bits addresses stored in the compiler. So you'll get your output will be something like this, I guess. Okay. In the same breath, let me tell you about buffers also. Buffers, you must, if you are YouTube, you must be, if you before we had 4G, you must be seeing buffering in YouTube videos. So buffers are memory storage regions that temporarily hold data. For example, there's a data in C, and we are shifting this data to A. So sometimes or in these kind of transactions, so sometimes there are storage regions which are buffers with that temporarily hold the data while it is being transferred from one location to another. So they are called buffers. There was just two terms because from pointers I got reminded of it. Let's now learn about some library functions. See guys, we have learned about strings, but to do some programming on strings, we need some library functions. So we'll learn about them and then we'll go to programming before calling it a day. Um, See, of course, if I hope you remember, library functions are the standard functions which have already been provided with the compiler, which you can use. And apart from that, of course, you can make your own user-defined functions. We have learned about user-defined functions. Now let's learn about some library functions. One of the very easy library function that gets function. See, this function is already present in the stdio.h header. Okay, like printf and scanf, it is used to take input of strings. It makes it taking input of string very easy. I'll show you an example. For example, char name 20, right? Now printf enter name. Let's not go in the printf statement too much. Then you can just write gets. Basically, it's the acronym for get string. So it just takes the input instead of writing scanf, then the format specifier for string. You can just write gets name and it will take the input. Okay. So it is as simple as that. There are some limitations to this function. That is why we don't always use it, but you can use it in general programming. The only one of the limitations is that it doesn't check whether the size that you are entering is compatible with the size of your character array, that is a string. So, but that's okay. Generally, we can take that risk. Puts function put string. So basically, it does the function of the printf function. So if you have taken input here, now you can just print it like this, puts name. You don't need to use any format specifier because this s letter already tells that it is a string. So you don't need any, the compiler knows that you are working with a string, so you don't need to put any format specifier. Okay. So these both the functions gets and puts were present in the standard input output header. Okay. You don't need to import string.h for working with them. Now let's go to math.h. This is the mathematical function header. It contains most of the mathematical functions which we might be using if you're making some programs to work with mathematical functions. Some examples can be, there's the sign function. You can give the output of the sign of the variable, cos, tan, but we don't generally find much use of it. Then there's floor function and seal function. Let us discuss about these two. See, floor function, what it does, it takes a floating value as input. Okay. For example, if you enter 7.46, so there is, if you are writing this, so there is a upper number which is the closest integer and the lower integer which is closest to it. So it always rounds it off to the lowest integer. Okay. So the output, if you write like floor 7.46, so the output will be 7. Okay. And seal function, seal comes from ceiling. So what is the ceiling of 7.46? 8. So if you do seal 7.46, it will give you 8. So remember that these functions are not rounding off, they are just giving you the upper integer and the lower integer. Just to check whether you have understood it properly, can you just tell me the value of floor minus 3.1? What will be the value of this floor minus 3.1? Minus 4, right? Yeah, right. So floor minus 3.1 will give you minus 4 because it is minus 3, minus 4, minus 2. It goes like this. So the floor of minus 3 is minus 4 and seal of minus 3 will be minus 2. Good. Yes. Now some of you can ask that, okay, then what about if we want to round up a number? Once again, floor. Okay, see, floor is just like, for example, Let us understand it like this: 1, 2, 3, 4. Now, if you look at this number, anywhere between this 3 point something, 3 point something something. So, what is the floor of this number? Floor. Just assume like your house floor. So the at the bottom of this number is 3, and the ceiling of this number is 4. So anything if I give you 3.76, 3.21, the ceiling will always be 4, and the floor will all sorry, the ceiling will always be 4, and the floor of that number of these decimals will always be 3. So similarly, I asked you what will be floor of minus 3.21. So just write it like this: 0, minus 1, minus 2, minus 3, minus 4. Now here you have minus 3.21. So what is the floor? For floor you always go down, so it is minus 4. And if I ask seal, then you will get minus 3. Yeah. Okay. Now you can ask, how about if you want to round off a function or a number? So there is a round function also, okay, but it is, keep it in mind whenever you are using it, that it is a bit different from the round we use in maths. What we do in maths is 3.1 to 3.4 को round off करेंगे तो we get 3.0, and 3.5 to 3.9 we get 4.0. This is in maths. But in computer, 3.1 to 3.5 will give you 3, and 3.6 to 3, of course by 3.6 I mean more than 3.5, greater than 3.5, greater than 3.5 to 3.9, it gives you 4. So if you have 3.5, then it is not rounded up to 4, but it is rounded up to 3. This is something that you need to keep in mind. Apart from that, it works fine. You can use the round function wherever you need it. Okay. Then there is a function called a very famous function, sqrt, square root function. So it just gives the square root of a number. For example, if you give sqrt 25, so it gives you 5. Okay. Of course, the output of these data types is float. So even floor and seal, if you are giving minus 3.21 and you're taking its floor, so its floor will be minus 4.0. So the output is in float. Okay. But even if you store it in int, it will just get truncated to minus 4. From truncate, I got to remember that there's a function called trunc. So this is truncate. Trunc is the short form for truncate. Truncate basically means cutting off something. So if you in truncate, if you give a float value like 7.23, so it just truncates its decimal part and returns the integer part. Okay, so 7.23 becomes 7. So it is used to just cut off all the decimal part and return you a proper integer. There is one more maths function called POW. It stands for power. So if you write like this, POW A comma B, so it basically returns you A raised to the power B. Okay. The same thing you can also do by using the power operator. But still someone found it cool to make a separate function. So if you like it, you can use it. No problem. Okay. Then there is a header file called ctype.h. So it has some character functions. Let us learn about them. There's a function called is alpha. Now remember that there is no space in between the function name. Okay, even if you are creating a user-defined function, it is basically, what is a function name? It is basically a variable name, right? You can create a function, your own function, you by the name Rohan, or Rohan is cool, anything. So the rules for creating variable names also apply to creating function names. So in variable names, if you remember, you cannot put space. Therefore, in function names, there won't be space. So is alpha is a function. Okay, it just checks whether the character is an alphabet. Okay, so I hope you know what is the output type, data type of this function. What will be the output data type of this function? It basically checks whether it is an alphabet or not. So it will tell true or false. If it is an alphabet, so the output will be true, and if it is not, then the false. Yes, basically Boolean. The output data type is Boolean. Then there is a function called is digit. So it checks whether the character is a digit or not. Then there's a function called is alnum. Basically, is it alphanumeric? So is whether it is alphabet or number. So that will be checked by this function. They're very similar functions, not difficult to remember. Then there is a function called is lower. So it checks if it is alphabet and if it is in if it is in lower case, so it will return true. For example, if you do is lower small a, so the output will be true. But in case of small a, if you give capital A here, so the output will become false. Okay. Similarly, is upper checks whether it is in uppercase or not. Then there is a function is space. It checks whether the character is a space or not. Okay. Then there are manipulative functions. See, all these functions that we did till now in ctype.h, where their output data type was Boolean, true or false. But now we have some manipulative functions. For example, to lower. So if you give an input character and it is an alphabet, so it will be converted to lowercase. If it is already in lowercase, so it will remain as it is. If it is in uppercase, it will convert it to lowercase. Similarly, we have a function called to upper. Now tell me what will be the output data type of these two functions? Yes, so it will return basically return a character. So we can store it in a new character. ch1 is equal to 2 lower ch2. So ch2 will be converted to lowercase and stored in ch1. Of course, ch2 has to be an alphabet. Similarly, to upper function is there. Then there is a function called is punct. Basically, it checks whether the character is a punctuation or not. If it is a punctuation, then it will return true. Now let's learn about some. So that was all about ctype.h. Now we learn about string.h. This s is small. You don't get confused that it is capital. Okay. So we'll learn about some functions in ctype.h, string.h. These can be some useful functions. So yeah, one of the functions, the basic function is strlen. Basically string length. So it gives you the length of the string. Okay. Length means what is the significant storage data that is stored in it. Of course, if it is a sentence, so the space is also considered in length. Okay. Don't just think that only the alphabets will be counted. We have a sentence and there are 3 spaces in between, so those spaces will also be counted as a length. But the null character which is stored at the end of the string, that won't be counted. Okay. So for example, there is a char name 0 and I have not given size here. Okay. Now int lengthgth is equal to strlen name. But guys, remember that if you're using this function, you have to import this header file in your program. Okay, otherwise it will give an error. Okay, only after importing #import string.h, only after then you can use strlen function, string length function. Okay, we'll do some programs on these, don't worry. Then another function is strcat. It's not cat, it's catenation. It's short for catenation, basically concatenation. So concatenation is the process of joining two things end to end. Okay, if there's this thing here and this thing here and you join them end to end, this is concatenation. So strcat basically concatenates two strings. For example, strcat string 1 comma string 2. So basically what it does is, if your string 1 has hello and string 2 has world, so the output will be hello world. Of course, it doesn't print it, it gives us a string, so you have to store it in another string, and then for example str3, and then if you print that str3, then you will get hello world. It's not that strcat prints it, it just concatenates it, and the output data type is also a string. I hope these things are clear, guys. They are simple, but just for the sake of knowledge, in case you have to use them, so you should know which function does what. Then there is a function called strncat. Okay, s1, s2, n. So what it does is it concatenates, but it joins only the first n characters of s2 string. Okay. For example, if I write str ncat s1, s2, 3. S1 has hello, S2 has world. So the output of this will be a string which will look like hello WOR. That's it. Because only the first 3 characters of the second string will be concatenated. So basically it trims the S2 according to the input data, and then it concatenates it to S1. Then there is str CPY. See guys, it is just string copy. Okay. So yeah, for example, this is to copy the contents of the second string to the first string. Okay, so if everything from second string we have to copy in first string, we just use str copy cs1 s2. Now one thing that you need to keep in mind is that the size of the first string which has been created should be such that it can accommodate all the contents of the second string. Okay, for example, uh, char s2, then I create a 20 sized s1, and then I can of course use str cpy s1 comma s2. But if s1 size was 3, then you can't use it. Of course it will throw an error. Okay, similarly on similar lines we have str and cpy. I don't think it's a mystery how we use it. It just copies the first n characters of the second string into the first string. So basically it first trims the s2 and then it copies it to s1. See, you might be thinking that why are we using copy function? So it's because these are actually character arrays, so you can't just copy directly using an assignment operator. So if you have a cpy function, so it helps in doing us that. Otherwise you have to run a for loop and then you will do it. Okay, then we have a strcmp function, string compare. So how does it compare? It basically does lexicographical comparison. Lexicographical comparison basically means the order of dictionary. So dictionary wise comparison is done between S1 and S2. You can just remember it by an analogy like S1 minus S2. You can't write like this S1 minus S2 to get strcmp, but it is an analogy. For example, I'll explain it to you. What it does is it tries to match the two strings character by character, and once it finds one unmatching character, so the difference of their ASCII code is printed. Okay, for example, if I have s1 is equal to uh, anything apple, and s2 is equal to capital Apple, or maybe small a but capital PPLE. Now if you do strcmp s1 comma s2, see what happens. The comparison is started from here. So the first letter, small a, they are same. So then the compiler looks at the second letter, small p and capital P. They are different. So as soon as an unmatching pair is found, the ASCII code of capital P and the ASCII code of small p and the capital P are found. Okay. Let us assume, I don't remember exactly. Let us assume the ASCII code of small p is maybe 107, and the ASCII code of capital P is maybe 72. Okay. So 107 minus 72, which is 35 will be your output. So strcmp will give output as an integer 35. Now just assume that both these S1 and S2 has had exactly the same strings, A, P, P, L, E in small in both the strings. Then what will be my output of strcmp? Tell me. Yes, 0. Very clear. Now there is a function called strchr. Okay. What it does is it uses pointers. That's why it was necessary to tell about pointers beforehand, but I had forgot to think of it. So it returns a pointer to the first appearance till the end of first appearance of C in S1 till the end. For example, if you have a string like this is India. Now, if you're looking for if you do like this, for example, if you use this function with the character, for example, S. So what is the first appearance of S? Here. So right from here till the end, this entire thing will be referred to in that pointer. Okay. And if it is not found there, if this character is not present in your string, so it will represent null. I mean the function will return null. Let us see this by an example. It's a bit confusing sometimes. For example, char s1 is equal to hello world, and then char c is equal to w. Then of course I need a pointer here, character pointer, so I use char star p. Star is referred to say that it is a pointer variable. Okay, because the function returns a pointer data type, so therefore we need a pointer variable to store the output of the function. strchr s1 comma c. We used s1 only, right? See, now what do you think the value stored in this will be? It will store from w till the end, that is world. So if you try to print the pointer function here, see, when we use the percentage s data specifier, format specifier, then the compiler prints the value of that pointer. Okay, so basically the value of that pointer is all these addresses, so the entire world will be printed. If we had to print the address, then we would use percentage %p specifier. See, this function will come very handy when we do it in some programs. I'll show it to you. Now let us do some programs. This is almost all the theory that you needed. Okay, and we have already done most of the programs in the class between the theory parts, but still we'll do some more now. Okay, now let us try some programs before we back the class. Write a program to enter a string and print the number of vowels in it. This will also make it clear to you. There are many ways to do this. Okay, just take an attempt, and I'll try to do it by using a function so that function also becomes clear, and that is one of the shorter ways, so it will be easier. Yeah, just take an attempt, guys. Do take an attempt, even if you feel that you don't know it completely. Taking an attempt will help you in building your own algorithms. You will also realize where you are making mistake. If I do it directly right away, so it will not help you develop your own thinking. So take an attempt. That's why I gave it time to 3 minutes so that you can take an attempt. And not just for checking vowels. For example, if you have to check whether some letter is present in a character or a sentence or not, so strchr function can come handy there. If you're using it, then remember that if that character is not found in that string, then strchr function returns null. Okay, we have to take the input from the user, so we just create a random string of any size. Okay, then printf enter string. Okay, I'm just using the gets functions just to demonstrate you that you can easily use it. Then I make a string of my own containing all the vowels. Okay, what are all the vowels? A, E, I, O, U capital and A, E, I, O, U small. So if a character is a vowel, it will be present in this string VOW. Okay, now what I have to do, I just have to extract each and every character from the name string which the user has given, and then I have to check whether that character is present in this string or not, and if it is present, then I'll just count it using a counter. Let's see how we can do that. uh, First we have to need to find the length of the string, because we don't know how much data the user has input. And this is needed only to run the loop. Okay, for int I is equal to 0, I less than L, I plus plus. If you can't remember this function here, you can just run it till 50, because the size of our variable is 50, so you can run it till 50, no problem. Just to reduce the number of times the loop runs, I found the length and I used it as a better coding practice. Now I can use a character. I can store the current character. This is a data type char. You can declare it earlier somewhere. Okay. Then if if strchr wow ch. So basically what it does, it checks for the ch character in the wow string, and if it does not return null, you can directly write null as capital NULL. If it does not return null, what does it mean? It means that ch is present somewhere in VOW, which means that ch is a vowel. If it does not return null, then we can use a count plus plus. You can create a count variable here somewhere. Int count is equal to 0. So if ch is a vowel, then count plus plus. Okay, this will count all the vowels, and then you can easily print them. Vowels are %d, count. See guys, this statement that I've written here is, instead of this, you could also write a big if statement like this. In fact, if you go in the book, you'll find it there. So since it is already in the book, and also it is very common, you must have seen it also if you have done a little bit of coding. So I didn't do it that way. You could have done it like this: if ch is double equal to capital A, or ch is double equal to capital E, or similarly I O U small a small e I O U. So you can write 10 lines like this, I mean 10 parts like this. So this will also do the same thing, but I think that was a better way, so you can use it that way also. If anyone had, this is the only core here. I'll also show you the execution of this program. Just hold a second. Yes guys, just have a look at this program. This is the same thing that I wrote just now. Maybe sometimes if it's all in one page, so it becomes more clear. Just have a look, then we'll execute it. Let's execute this. Enter name Kritika. Vowels are 3. Okay. I'm hoping that this program is clear to everyone. Okay. So we can move to the next program. Write a program to enter a sentence and count the number of words in it. Enter a sentence, take an input of a sentence from the user, and then count and tell how many words are there in the sentence. And I'll remind you, this functionality you must have seen when you write something in MS Word or somewhere. So they tell you in the bottom left, they say how many words you've written. So this is the kind of programming we use. Okay. Now just think how what separates one word from another, and then on the basis of that you can maybe try this program. If you're writing anything in MS Word, so they keep telling you how many words are there. Okay, guys, take an attempt. It's an easy program, and you can use some things which we used in previous program. See, most of the part it's same. For example, for a sentence, we create a character array, maybe of size 50. Okay, then gets line. Of course, you can give a printf statement. I'm not giving it right now. Then int l is equal to strlen line, so it calculates the length of line. Then for I is equal to 0, I less than l, I plus plus. Now every time we get a character, line I, this is a character, it can be declared here. Now if ch is double equal to space, just you can give a space here and put a single quote, so put it in single quote, so it makes it a space. C is equal to C plus 1. So it will be counting the number of words, and you can print them. Now, is this program right? I've made a small error in this program. Just have a look and tell me what is that error. Just have a look. The output of this program will not be correct. Every time I'm taking out a character from the string, and if it is equal to space, I'm doing C equals to C plus 1, so I'm counting it and I'm printing it. See, we are counting the number of spaces, but we have not added one to it. This statement just counts all the number of spaces, and you should first do C++ before printing it. Otherwise, it will only print the number of spaces. We want the number of words. Or else, another way can be to not initialize C with 0, but initialize C with 1. Make C equals to 1. So it's already having 1. So then you don't need to put this C++, and the answer will be correct. So either start with C equals to 1, or after counting the number of spaces, do C++ or C is equal to C plus 1. So because the final required output is the number of words, not the number of spaces. They are not equal. Number of words is equal to number of spaces plus 1. Okay. Okay. Anything else? Has everyone understood this program clearly? You can have a look at the complete program once if you want. So if we take given input, life is awesome, so words are 3. Okay, I hope this program is clear. If there's any doubt, please tell me. Okay, so let's move to the next program. Okay, write a program to enter a character and check whether it is alphabet or not. See guys, you can use a function here, is alpha, but if you're using it, keep it in mind that first you have to import ctype.h. Okay, without importing the ctype.h header, you can't use it. Yes, but I'll that makes the program very easy. So to make it a bit more challenging, why not try it without using the function? Try doing this program without using the function. Using the function is very easy. You just have to import c-type.h and use is alpha. Let's see if we can do it without using the function. What we can follow here is, let's try this. Char c printf, enter a character, scanf. So the user has input a character. Now see there, what I can do is, one technique is int a equals to c. Now what will this statement do, guys? Tell me. See, I'll tell you. You're forgetting that. See guys, what is happening here, you have forgotten. It is implicit typecasting is happening here. So basically character is a smaller data type and integer is a bigger data type. So the compiler automatically converts C to its ASCII code and stores it in A. So the ASCII code for small b is 98. So the value of A will be 98. See why we are doing this here is, there's a very simple reason. This is implicit typecasting. Okay, don't forget. In char to int is it's implicit typecasting. You can do it. Why we are doing it here is, see, ASCII code 65 to 90 is capital A to capital Z. ASCII code 97 to I think 122 is small a to small z. And if I'm not wrong, 48 to 57 is 0 to 9. Okay. Let us just assume that this is true. It is near to that, maybe 48 or 45, I don't remember exactly. So to use this, we have converted C to its ASCII code. Now it becomes simple. We have to check for alphabets, right? So we'll write it like this. If A is greater than equal to 65 and A is less than equal to 90, it means that A is any capital letter, or A is greater than equal to 97 and A is less than equal to 122. If this is the case, then printf it's an alphabet, because it can either be a small alphabet or a capital. So we checked for both the ranges. This is the range for small alphabets and this is the range for capital alphabets. And remember that there is or sign in between. Yes, return 0 you can do if your main is int. Yes. So after this I can write, if this is not true, then I can print else printf not an alphabet. I hope this program is clear to everyone. And see guys, this understanding these is also important. See why we are using and here and or here. Be clear about it. And is because a greater than equal to 65 can even be 165. So it should be greater than equal to 65 and less than equal to 90. Only then it is we can be sure that it is a capital letter. Okay, that is why and has to be here. I hope this program is clear. See now this statement can also be written. See here what we have done is, this is the line where we have done implicit typecasting, right? Now this implicit typecasting can be done in the if statement directly also. I'll show you how we can do this. I could have written that statement like this. See, I had ch, c, I have add the character stored in c. Now look here, I'll directly use that. I'll write it like this. If c is greater than equal to small a and c is less than equal to small z, or c is greater than equal to capital A and c is less than equal to capital Z. Then also we can do printf C is an alphabet. Now see what is happening here. Real time typecasting is happening. See, this is an relational operator. So for it to work on characters, it will automatically convert the character to integer. So C will be converted to its int type, and small a will also be converted, and then this operator will check whether it is true or not. I hope you have understood. Print prime numbers between two intervals. You have to take input from the user, two numbers, and all the prime numbers between those two numbers should be printed by your program. Just take an attempt. So the question is that you take the inputs from the user. For example, if the user gives 23 and 77. So all the prime numbers between 23 and 77 should be printed. Now, for doing this program, we have to understand what is a prime number. A prime number is a number who has only two factors, 1 and itself. So if we can count the factors, and if the factor is equal to 2, then we know that it is a prime number, right? So we'll do this program here. For example, let me just first take two variables from the user. Okay, so start and end. Now for I is equal to, if n mod 2 is equal to 0, not a prime number. Okay, so what we'll do, we'll start from I is equal to start, we'll end at I is equal to end, and of course I plus plus. Okay, so now we will get this loop. What it will do is it will give us each value between that range one by one. Now we have to check whether that value is prime or not. So first we have to count the factors. So for each value, first we'll put fact equals to 0. I'll explain why we are putting this here. Okay. Then we start another loop. For j is equal to 1. See, the factors can be only from 1 till that number. So j is less than equal to I. J plus plus. I is our current number. For example, if 23 and 77 are there, assume that I value is 45 right now. So we have to check whether 45 is prime or not, right? And if it is prime, then we'll print it. So j has to start from 1 till 45. I's value is 45. Now we have to check whether the current value j is a factor of 45 or not. So if I mod j is double equals to 0, fact is equal to fact plus 1. See, fact is equal to 0. Here we are counting the factors of I. I is 45. So if j is a factor of I, then just count it in fact. As this loop gets executed, all the factors of I will be stored in fact, right? I mean the number of factors, of course. Now what we have to do? We just have to check if fact is double equals to 2. If there are only two factors, this means that, or you can also do this, that j starts from 2 and goes till less than 45 by 2, and if you don't get any factor in this range, then also it is a prime number. So you can manipulate it according to you. You are right there. I'm just doing it in the simplest way possible. Okay. Okay. Then we can printf. What will we print? Who is the prime, I or j? If fact double equals to 2, which is our prime number, I or j? I. Very good. So we'll print percentage d slash n so that there is no confusion. I. Okay. And we end the loop here. Now see what happens. For example, I is equal to 45 has been checked, right? Now when this I loop gets in the next round, When we go to I equals to 46, again we have to count the factors from the start. That is why as soon as we enter this loop, we must make fact value equals to 0. Otherwise, the number of factors that have been counted for 45, in that only it will still count the factors of 46. So we want to start a fresh counting for a fresh value of I. So as soon as you enter the loop, you must make fact equals to 0. Is this question clear to everyone? Just have a look. Try another question. Write a program to, it is a simple question, find the length of a string without using the strlen function. You don't have to use this function, but find the length of a string. If you remember, I told you that in the end of a string, the compiler always stores a null character just to which specifies that the string ends there. So using that null character, you can know where the string is ending. Let's try to do this. Enter a string. So I've taken an input here. I is equal to 0. Condition I can put stri is not equal to. We represent a null character like this. We can represent it like this. And of course I plus plus. So see, this will keep counting till all the indices unless the character is null character. If the character is null character, then it will come out. Now see, I can also do this program in this way. I'll put a semicolon here and then I'll print length equals to. Now guys, did you understand this program? See, there are two important points here. This program will help you understand the running of the loop and then understanding where what this semicolon does. See, there is no statement within this loop. It's just that this loop will run until the stri becomes equals to null character. As soon as the null character is received, the loop will end. There are no statements within the loop. That is why a semicolon just after the for loop. Okay. Now assume that you have entered the letter as apple. Okay. So I starts from 0, 0, 1, 2, 3, 4. Then when you go to I plus plus, that is I equals to 5. So here there is the null character. So as soon as this null character is encountered, the loop gets terminated, and the last value of I was what? 5. So there are 5 letters, so I is printed. Now there's one other important thing that you should remember in this question. If you do it this way, this I, you need to declare it above. Okay, somewhere. I'll declare it here. Int I. If you declare it here, int I equals to 0, then this program will throw an error. Why? Tell me. Tell me why this program will throw an error if we declare I here in the for loop. This is because it will take an ASCII value. No. See, if we declare it here, this means what? It becomes a local variable for this for loop. So as soon as this for loop gets terminated, this I variable will be deleted. It will decay. Okay. So you cannot print it after the for loop terminates, because it is a low. If you declare it here, it is a local variable of this for loop. It has no life outside of the for loop, so you cannot print it here. If you want to print it here, then you have to make it a global variable, at least for this not for this. As far as this for loop is concerned, you have to declare it above the for loop, so that the I variable does not die as soon as the for loop terminates. I hope it is clear. So if you don't want to do that, you can use a counter here. C is equal to C plus 1. So that is also good. Okay. No, the I will always be 0. No, I hope you understood the reason. Take an attempt this last question. Write a program to enter a string and count the number of vowels, consonants, digits, and spaces in it, or words in it. This program is basically a continuity of the previous program which we did with vowels. So I'm just continuing from there. Okay. If you remember in the for loop, we have taken out the character. For example, if I have taken out a character, ch is equal to name I. Okay, I'll not write it like this. Somebody can get confused. I'll write from the for loop. For I equals to 0, I less than L, I plus plus. I hope you remember L was the str len of the. Okay, sorry. Ch is equal to name I. Wow, ch not equal to null. Then we have a variable counter for vowels. We just increase it by 1. So this will find check if it is a vowel. So it will increase v by 1. Now we'll use else if. Now see, if this is false, only then the control will go in else if. So if the control has come here, we already know that it is not a vowel. Now if it is not a vowel, then we can directly check it like this. See, ch is greater than equal to small a and ch is less than equal to small z, or ch is greater than equal to capital A and ch is less than equal to capital Z, then we can have a variable counter for consonants which we can update here. Now see, here we are checking for all the alphabets, but just know that if it was a vowel, it would already get stuck in the first if statement. So now if it is an alphabet and we know that it's not a vowel, so definitely it will be a consonant, right? Now after that we can check for digits, else if ch is greater than equal to 0 and ch is less than equal to 9, then digit plus plus digits, this is a counter variable which starts from 0, and else if ch is double equal to space, then words plus plus, and this words variable will be starting from 1. The initial value, the digit, this variable, its initial value will be 0 at the beginning of the program, but for this variable it will be 1 because words will be always 1 more than the number of spaces. Okay, I'll show you the execution in the okay, but I hope you guys have understood it. If you want, I can write it and show you if there's any clarity, lack of clarity. Okay, I can show you this here. Let me just show you. See, here we have done it for vowels. Then we check else if ch is greater than equal to small a and ch is less than equal to small z, or ch is greater than equal to capital A and ch is less than equal to capital Z. We created a variable like con plus plus, right? We can declare them here 0. Then we can do digit equals to 0, like words equals to 1. Okay, else if ch is greater than equal to 0 and ch is less than equal to 9, what is it, digit plus plus, else if ch double equal to space then words plus plus. Okay, but we need to print them also, right? Vowels are percentage D. I'm just printing them here. So we have C, then CON, then DIGIT, and then words. Everybody is correct? 4, 4, yes. Okay, let's run it. You can see the output. I hope this program is clear to everyone. Basic programming, but still, guys, I'll recommend that you do practice of the programs. There are some other programs which are there in the book, so please go and try them as well. First, try them on your own, then look at the solution. Don't look at the solution beforehand. And yes, and from next weekend we'll be starting with Arduinos. Okay. So if there's no doubt, we can end the class here.